Hello and welcome. So let's get right into it. We're graphing transformations. First thing you always need to do to graph any transformation, figure out what your parent function is. We have three kinds we're looking at today: quadratic, square root, and absolute value. Quadratic is going to be that U shape. Square root, I call it the half seagull. And the V is your absolute value. Keep in mind that when graphing these, your vertex must be the first point that you use. If not, it'll be wrong. Alrighty, so looking at this one, I'd say, okay, we see that square, that means we're going to have the U-shaped graph, or quadratic. Now, the pattern for a quadratic is as follows. For this one, it starts at 0, 0. And we can tell what the pattern is by just plugging in the points, right? You plug in x, you get out y. So if you plug in 0, 0 squared, 0. Your next point is at 1, 1. Plug in 1, 1 squared is 1. 1 comes back out. You plug in 2, 2 squared is 4. So essentially what your graph does, it starts at 0, 0, then it goes over 1, up 1, and over 2, up 4. And that is your pattern for quadratics. So for this one, all we need to do is we need to figure out, okay, patterns. Where are your transformations and what are they? So first thing, let's deal with the easier one first. We have this -5 that we see on the outside of the parentheses, outside of the square, which makes it a vertical transformation. Now we know this is not a shift because that -5 is being multiplied to the parentheses, meaning that it is a stretch or shrink. Specifically, it's a vertical dilation. That kind of means either or. Okay, if we want to be really specific, this will be a stretch. Okay, because it's a number larger than 1. For vertical transformations, you do exactly what you see. So I'd say, okay, it's multiplying -5 to the operation, to the parentheses. So that means that what you're doing is that instead of going over 1 up 1, it's over 1 up, or down, because it's negative, down 5. So that means you're going to be going stretching -5. Okay, we also have to worry about our inside transformation as well, because it's not just going to be, multiplying the -5 to the 1. Okay, we also have something that's going to affect the 1 on the other side that's being multiplied to it. Okay, and that's going to deal with that -2. If the other one is vertical for the outside, that means this is a horizontal dilation. Whoops. Okay, specifically, this one's going to be a shrink or compression with a reflection. It's a reflection because it's negative. Alright, so I look at this one, I'd say, alright, well, horizontal dilation, in other words, shrink, and we know it's a shrink because when it's on the inside, you do the reciprocal of what you see there, because it's multiplying reciprocal. So it's alright, so that's -2 over 1. The reciprocal of -2 over 1 is -1 over 2. Okay, so if you're going right 1 up 1, then that's going to be left a half and down 5. So we start at 0, 0. That's always true, 0, 0, unless you have a shift. And then left half, down 5. This is your second point. Okay, now the reason why we went left 1/2 was because normally what we do is we go to the right 1. Well, if it's +1 times -1/2, that means -1/2. You're going to the left 1/2. Okay, this next one is going to be +1. Okay, times by -5 means down 5, because 1 times -5 is -5. So that means your next point is down 5 from there. And then you just essentially just need to connect your dots. Because it's a quadratic, you have the symmetry. There's that second point on the other side. All you need to do is you all just need to have at least your vertex and one other point where it's going to continue on. It's going to be very steep increase. Okay. Not the most beautiful quadratic, but it does the job, I guess. Remember, first job, First point, always the vertex, and then you could choose either of these 2 points to graph it, and then your tool will graph it for you. So just keep in mind, follow your patterns. Right? And that's all there is to it. Thanks for watching.